So, if you're watching this video, you have hopefully completed the 15 episodes of how to create a Vampire Survivors clone in Godot 4. If you have, then congratulations! You have a solid foundation project to create your own survivors like. A question you may be asking yourself is, what's next? And in this video, I hope to lead you towards a direction that you're satisfied with. This video isn't going to be like the previous ones where I show you how to make something in a step-by-step fashion. Instead, I'm going to be talking about ways to improve the tutorial, as well as add your own spin to whatever has been already created. The easiest way to start making your own adjustments is by making new enemies, attacks, and upgrades. For enemies, you just need some sprites, and away you go with the export values. New attacks may require more effort into making their unique effects, but whether they are persistent effects or projectiles, you should be able to leverage what has already been made to create something unique. Upgrades are pretty simple. If you wanted to increase your pickup range, for example, you would just need a sprite, add something to the item DB, and then some code in the player scene to increase the pickup range, and voila, you have a new upgrade. You could also start making new functionality like adding random drops. So if you wanted to add an experience magnet, you could make it so that the enemy has a 1 in 100 chance to drop an item that increases your player's grab area collision by, let's say, 100,000%. There is so much potential to alter this tutorial, and it's really up to you to decide what you want to add. For your ideas, you may need to find other tutorials, do them, and then leverage what you've learned to make changes into this project. Now, let's talk about some improvements you may want to make moving forwards. First of all, I feel like we could do a significantly better job at leveraging classes for our shared enemy functionality. At the moment, we do share a script, but the node structure is duplicated, and if we need to make a change to all enemy node structures, we're going to have to do this multiple times, which can lead to issues. So what I've done is create a scene that has all of the child nodes other than the collision shape 2D and the animation player. I've then also created a script called enemy_body.gd, which has the class name of enemyBody. It has everything the enemy.gd script had, but we've changed the onReady variables to match the new node structure, and we have connected the signals via code. Afterwards, we just make the enemy.gd script extend the enemy body, and now we have the enemy inherit all of the enemy's based AI, in addition to giving us some potential to add unique AI to the specific enemy as long as it extends the enemy body. Shared functionality is often the way to go, and hopefully this can showcase a better way of doing enemies in the future. Next, I want to talk about optimization. I tend to find that when I reach 500 enemies in my debug world that I begin to face some performance issues. There are going to be countless ways to optimize performance. I'd like to focus on some potential easy wins, but if you know anything better, feel free to write up a comment. The world that I'm debugging in is just a duplicated world scene with the enemy spawner set to add 100 enemies every second for 5 seconds. First of all, I read that circle shapes are actually the most efficient collision shape since it only needs to check distance from the radius rather than checking an X and a Y value, so there's a minor save there in comparison to the capsule collision shape. For a slightly bigger change, I put a cap on the amount of enemies I can spawn at a time. At the moment, this is 500, and what I do is that every single frame, I check the amount of enemies that we currently have as children, and I check if that is below 500. And if it is, then we proceed as normal. However, if it is above, I insert the enemy that I was going to spawn into an array, and then check in the same timeout function if we have finally gone below that cap. If we have, then I'll spawn the first 50 enemies in that array into the scene, and then remove them from the enemy backlog. This just means that we've capped the amount of enemies we can have active at a single time, while keeping track of the enemies that we have withheld from spawning. I also now have a timer on the enemy, which is going to check the location of the enemy from the player. In general, every single 0.4 seconds, we will check if the enemy is way out of the camera range, and if it is, we're going to set the enemy's visibility to false. If not, we'll set it to true, effectively making it so that the GPU doesn't need to draw things that we don't even see. The final optimization I'm going to show is a function I added to each enemy called frame_save. And what it will do is, based on the percentage chance argument, disable the enemy's collision shape and stop the walk animation. This is pretty significant, so I only ever want to do this when it is absolutely required. And the way I determined this is by a new scene I called the frame saver. And what the frame saver does is check what the frame rate of our game currently is. I have disabled VSync to get the variable frame rate, and based on where we sit, it will call the enemy's frame_save function. If the frame rate goes below 55, then we disable 20% of the enemy's collision shapes and animation. If it's below 70, it's 10, and if below 85, it's 5%. This way we can hopefully smooth out any potential big frame rate drops before it becomes a major issue. This is limited to run every 0.5 seconds, since it may take a couple of frames for the overall frame rate to properly recover. The idea of this is to only impact gameplay as much as it's needed. Other than that, it's really up to you how you alter this tutorial. My advice will always be try to improve the tutorial after completing it. This lets you properly interact with the code and understand why decisions are made and how to leverage similar ideas for future games that you make. Otherwise, I'd really just focus on having fun. This hobby is a marathon, and the best way to get out of tutorial hell is to learn how to have fun making games before you learn how to make fun games.